This is the graph and problem that I will present in this video. The figure shows the graph of the derivative of function f prime. The function f is a twice differentiable function on the closed interval between 0 and 8. The graph of f prime has a horizontal tangent lines at x equals 1, 3, and 5. The function f is defined for all real numbers and satisfies f of 8 equals 4. In part A, we are asked to find a local minimum on the open interval from 0 to 8. In the open interval between 0 and 8, the critical points are x equals 1, 4, and 6, which represents f prime equal to 0. The local minimum means f prime changes the sign from negative to positive on a given point. At x equals 1, both sides are positive. F prime does not change the sign. At x equals 4, f prime changes the sign from positive to negative. At x equals 6, f prime changes the sign from negative to positive, which represents that f has a local minimum. Therefore, at x equals 6, f has a local minimum. In part C, we are asked to find open intervals that the graph of f both concave down and increasing. Based on the definition of concavity, f double prime less than 0 represents the function concaving down at f prime greater than 0, representing the function increasing. Therefore, we need to find open intervals that open f prime greater than 0 and f double prime less than 0. On the open interval x, which is greater than 0 and less than 1, we can tell that f prime is greater than 0, but f prime is decreasing as x increases from the graph. Therefore, x double prime is less than 0. On the open interval x greater than 3 and less than 4, we can tell that f of prime is greater than 0, but f of prime is decreasing as x increases from the graph. Therefore, x double prime is less than 0. So, on open intervals 0 to 1 and 3 to 4, the graph of the function f concaves down and is increasing. In part D, we are given the function g of x equals f of x cubed, and f of 3 equals negative 5 over 2, to find the slope of the tangent line of g at x equals 3. First, we find the tangent line of g based on the chain rule, which is g of x primed equals 3 f of x squared times f of x prime. Then, we find the slope of the tangent line at x equals 3, which is g of prime 3 equals 3 times f of 3 squared times f of 3 prime. As we already know, which is given, f of 3 equals negative 5 over 2. Based on the graph of f prime, we can tell that f prime 3 equals 4. Therefore, g prime 3 equals 3 times negative 5 over 2 squared times 4 equals 75. The slope of the tangent line of g at x equals 3 is 75. Thank you for watching.